My name is Kalle Lahtinen. I'm here to give you a short presentation about Novatron machine control systems and different AI-related applications we're interested in at this moment. First, a quick company introduction. Novatron Ltd was founded in 1991 in Tampere, and we're currently based in Pirkkala, Finland. Our main focus is earth-moving automation, which means that our main products are machine control systems, of which I'll tell a bit more in the following slides. And we're heavily moving towards digitalization of job sites and robotizing earth-moving machinery. We have about 130 employees, a little bit over, out of which 56 work in R&D related tasks. We do all the software development, mechanical and electrical engineering, as well as research, and the production and system assembly and installation in-house. Then a bit about machine control systems. Machine control systems in the context of earth-moving industry can be roughly divided into two categories called 2D and 3D systems. And the 2D systems are based on measuring all the moving parts of the machines. So we equip an excavator, for example, with IMUs on each of the moving part, and this measurement allows us to calculate the kinematic model of the machine. And this way we can always know where the tool of the machine is, which in the case of an excavator means the bucket, or the bucket blade actually is the interesting part. The operator then can use our system to measure distances to defined measurement points. So basically, simply put, a machine control system is a measurement tool for the machine operator. The more advanced version is the so-called 3D system, which works in a similar way as the 2D system, but on top of the IMU measurement we add GNSS positioning, which enables us to calculate the absolute location of the machine tool in the world, in world coordinates. And usually 3D systems are used together with a 3D model of the job site, which is called a building information model. So we can visualize the 3D model of a job site to the operator and show where the machine is on the job site, and the operator can select different job site structures from the model, and our system then measures the distance of the tool to the selected structures. And now that we know that we have these kind of systems available and in production, we can easily see that there's a lot of data to be collected. So we can, at the moment, we can measure how the machine is moving, where the machine is moving, what kind of measurements. We can do measurements from the pressures of the hydraulic components of the machine, how the machine is controlled by the operator with the joysticks, and with if we have a semi-automated system, then how the machine is controlled by the hydraulic control signals. And also we can collect data from the building information models, which contain information about the job site structure, different job site goals, and as well as the so-called as-built data, which is documentation data collected by the operator with our system. So as-built data is a term that describes documentation about what has been done on the job site so far. And in addition to these measurement modalities, we're also interested in researching how to apply visual data measurements within our systems, and also audio/acoustical data from the machine and the job site environment. This image basically summarizes everything I wanted to talk about here today. So the top half describes all the things I just said before. So we have these kinds of systems that measure these kinds of things, and then the top half, bottom half describes possible AI applications we are interested at this moment. So we hope to develop systems that not only give information to the operator but also take active part in controlling the hydraulics of the machine. This is the autonomous hydraulics control box. We're also interested in environmental awareness, so we can provide either the operator or the system controlling the machine information about what's happening around the machine and on the job site. We are interested in productivity and quality analysis, so that when we build something, we can analyze if we did it well or not so well and what we could improve in the future. We're interested in automatically collecting documentation about the work done on the job site, as well as quality guidance systems, so that the system could advise the operator to do their work better. And we're also interested in camera-based and assisted positioning to complement some of the weak spots of satellite positioning. The challenges we're facing are quite typical AI-related challenges. We need to research and do work on how to build and maintain well-working models that generalize well in the world, and this includes different modeling method comparison. So we need to know which modeling techniques work best with a given modeling task. We need to figure out how to implement large data collection and storage problems. We need to figure out what data is important in relation to a given modeling task, and what are the important features in that collected data. And also a specifically difficult question for us at this moment is how to implement data labeling for supervised training methods for machine learning, because the labeling, if we take for example the IMU data, which kinda tells how the machine is moving, but it's not very intuitive to a human being to read a time series of a accelerometer data, for example. So the data labeling and how to manually do that is one big problem for us at the moment, but also an interesting problem. And lastly, I have this really short demonstration video of our semi-automation system. This demo shows the operator using our fine grading feature. Fine grading means that we are finalizing some sort of a surface with the machine, and the feature works so that the operator only defines a desired surface level and slope, and then only needs to pull the main boom joystick behind, and our system takes care of moving rest of the machine parts in the process. This is just to show what's show the best accuracy we can at this moment reach with semi-automated functionalities on an excavator. I hope this works. If it doesn't work, it doesn't work. Ah, it works, yeah. Yeah, it's only 20 seconds, so basically the driver only needs to do one thing and the machine does the rest in this one, yeah. Yeah. And that's an example of a really difficult and complicated task that in the case of a human operator, it takes years and years of practice to do that well. And we hope to introduce systems to the market that reduce that time so we can take operators that are maybe not that experienced yet and help them do job quality work faster. Yeah. And that's it, actually. Thanks for listening.